afternoon. Today in our algebra review, we will be simplifying radicals. Our learning goal today is to learn how to factorize numbers into their prime numbers, so prime factorization. We'll learn how to simplify expressions with roots, and we will learn how to simplify roots with variables raised to powers. So those are our three learning goals for today. So let's start with our prime factorization. So what we want to do here is to find the prime numbers that if we multiply, we get our initial number. So let's go for an example, number 35. So we have here number 35, okay? 35, we want to find its prime factors. So the first we have to list our prime numbers. So let's see here, our prime numbers are 2, 3, 5, 7, 11, 13, and so on. Okay, so first we have 35. Can we divide 35 by 2? No, we can't. We can't divide it by 3 either. We can by 5. So 5, if we divide 35 by 5, so we can circle our prime number, our answer will be 7. So 7, we can't divide it by 5 anymore, but we can divide it by 7, which is our next prime number. So we divide 7 by 7 and we get 1. When we reach 1, that is our end. So 5 times 7, 5, a prime number, 7 a prime number, 5 times 7 equals 35. So this is prime factorization. We find the numbers, the prime numbers that multiply to get our initial value. So let's get another example. So 167. Okay, 167. If we divide it by 2 we can't, 3 we can't, 5 we can't, 7 no, 11. Get our answer will be 13. So our next 11 doesn't work anymore. So 13, we divide this by 13, and we get 1. So that is our end. So 11 times 13 equals 167, both prime numbers. So this is something very interesting. There's a different way we can do this, just a different structure. It's the same idea. So let's take for an example number 30. Now I will be using the stairs method. So the stairs method, let's say number 30, we make a little step here, and then we will put, so 30 we can divide by 2, so we will put the prime number on the left. So 30 divided by 2 gets us 15, so this will be our answer. And then we put another step. 15, we can divide 15 by 3, so 15 divided by 3 is 5, so our answer will be 5. And then another step, and then now it's 5, so 5 divided by 5 is 1. So this is our end. So these are the prime numbers that create our prime factorization. This is our prime factorization. So 2 times 3 times 5 equals 30. Is that correct? So 2 times 3 is 6, 6 times 5 is 30. That is correct. So this is our prime factorization using these two structures. I personally find this one clearer, easier to see, but that's up to you. Now we'll be going to some simplifying expressions with roots. Okay, let's see here. So simplify expressions with roots the easiest way to do this is to first list the perfect roots. So if we have square roots, or for squared, so what's 2 squared is 4, 3 squared is 9, 4 is 16, 25, 36, 49. These are squares that you have to memorize. These are squares that you know. They're perfect squares. And then let's say for cubes, so for cubes will be 8, 27, 64, 125, and so on. So now let's say we want to simplify a root. So let's say we have here cube root of 27. So 27, we know 27 is a perfect square. So 27 cube root of 27 equals 3. Okay, that's easy, that's simple. But what if we don't have a perfect square? Then what do we do? Well, let's say here we have cube root of 54. cube root, I'm sorry, I wrote that wrong, cube root of 54. Well then, since we know it's a cubed, we take our cubed list, and so let's look in here. 54, we can't divide that by 8, 54's, but we can by 27. 27 times 2 equals 54. So this 54 we can divide into 2 times 27. Cube root of 54 is the same thing as the cube root of 2 times the cube root of 27. So this 27, we know that it's a 3, it's a perfect square. So our final simplified answer is 3 times the cube root of 2. That is our simplified answer for this expression. Another example, let's use a square now. 68, square root of 68. Okay, square root of 68. 68, we can use 4 times 17 is 68. So 4 times 17. So 4 squared is 2. So square root of 68. We can use here 4 times 17. 4 and 17. So square root of 4 is 2. And then 17. So this is our simplified answer. You have to find the perfect square inside the value so that you can simplify the number. There's a different method you can do this. For example, let's say here we have this 54. Let's use prime factorization to find out this 54. I prefer this method, but you can use this other method as well. So let's say we have your cube root of 54. If you use prime factorization, 54 divided by 3. Now, first of all, we can do it by 2. So by 2, it's a first prime number, will get us 27. Then we divide it by 3, which will get us 9. 3 again will get us 3, and 3 again will get us 1. So 3 times 3 times 3 times 2 is 54. So 3 cubed times 2 equals 54. So the root of this, you can cross these out, so that will give us 3 cube root of 2, which is the same answer we got before. So that is how you simplify expressions with roots. But then you say, well, what if I have an x inside the root? Then we get to our last learning goal, simplifying roots which contain variables raised to powers. Let's say here we have here the square root of x to the power of 7. Well, actually, this is not that complicated. X to the power of 7 could be rewrote as x times x times x times x times x times x times x. 1, 2, 3, 4, 5, 6, 7. Then we have to root this. So if you root this, what you'll be doing, essentially, which is a concept of square rooting, every 2, you take out 1. 2, you take out 1. 2, you take out 1, and then there's 1 left. So our simplified answer for this will be x cubed times the square root of x. This is you have to rewrite it, it's quite complicated. So the easiest way to do this, so we know this is a 2 here, because it's a square. 7 divided by 2 is 6. 7 divided by 2 is 3, and then there's 1 left. So outside of the root, x3, 7 divided by 2, and then the 1 left, we keep inside the root. That is the easiest way to do this. Let's say we have different example. The root of x to the power of 8, y to the power of 9, z to the power of 12. Well, if I want to simplify this, 8 divided by 2 is 4, so outside of the root, just 4, nothing left. Y to the power of 9. 9 divided by 2 is 4, 1 left. So y, 4, and then inside the root we still have a y. Z, 12 divided by 2 is 6, so z to the power of 6. And that is our simplified answer for this expression. So that is how you simplify roots that have variables raised to powers inside. Now for examples, let's say here we have, so just that you understand perfectly well what we're doing here, we have the square root of 168 x to the power of 7 z to the power of 3 y to the power of 6 divided by 8 times z to the power of 4 y squared x to the power of 4. So first thing we have to do here is to get these numbers into perfect squares. So this will get us 168, so that's 4 times 4 times 42, so 4 times 42 gets us 148, and then 8, 4 times 2, so 4 times 2, and then we get our exponential laws, our exponential properties. So you remember when you divide variables with exponents, same base, different exponents, you subtract the exponents. So x to the power of 7 divided by x to the power of 4, 7 minus 4 gets us 3. So x to the power of 3. Z to the power of 3 divided by z to the power of 4 will get us z to the negative 1, or we can just keep it on the bottom side, so 1 over z. So the z stays down here. And then y to the 6th divided by y to the 2nd will get us y to the 4th. All this inside a root. So we know 4 and 4 will get us outside of the root 2 over 2, and then still inside the root, since we can't simplify that, 42 over 2. Then x cubed, so 3 divided by 2 will get us 1 and 1 left, so outside of the root just x, and 1x still inside the root. Y to the 4th, 4 divided by 2 is 2, nothing left, so y squared inside. And then this z, well, we can't simplify, it's only 1, so down here we would still have this z. Now we can continue our simplification, so 2 and 2 is just 1, so we can, this doesn't, it's unimportant. This x, since this is an even root, and outside, after our simplification, it became an odd, it's 1, you have to keep this in absolute values. So this will get us x inside the absolute, y squared, root 42 divided by 2 is 21, x, and then 1 over z will get us z to the negative 1. So that depends on how your teacher asks you to do it. If he doesn't want negative exponents, you just keep it like this. If he doesn't want denominators, z to the negative 1. And that is our final simplified answer for this example. So let's go to a second example. Let's go to a second example here. Let's say we have the cube root of negative 189 y to the power of 40 z to the power of 8. Well, this is actually simpler. 189, if we use our prime factorization here, we can see that 189, if we divide this, divided by 3 will get us 63. So this is our prime and this is 63. Then we can divide this by 3 again, which will get us 21. 3 again will get us 7, and divided by 7 get us 1. So we have 3 3's here, so we know that 3 cubed times 7 equals 189. So negative 189 inside this cube root here will be cube root of negative 3 cubed times 7 y to the 40 z to the 8. And then we can simplify all of this. So let's say we can strike these out. So outside of the root we will get negative 3. Inside we keep this 7. Y to the 40. So 40 divided by 3 will get us 13. So, and 1 left. So y 13, and inside we still have 1 y left. And then 8 divided by 3 gets us 2 with 2 left. So z squared, and then inside we still have z squared. And this is a cubed root. Very important information. So this is our final simplified answer for this example. Negative 3 y to the power of 30 z to the power of 2 times cube root of 7 times y times z squared.